Hi everyone. Welcome back to another lecture. So this will be the third lecture, and we finished not third lecture, fourth lecture, and we completely finished chapter one. Like we completely finished chapter one. We're not going to focus on chapter one anymore. And yeah, chapter one is finished. Just so chapter one is finished, and we're going to move to chapter two. My plan is to finish chapter two today itself. At least, like that's what my plan is. Finish chapter two today itself. Um, but yeah, we're going to see what's going to happen. So let this iPad, this pencil charge. All right, we are ready to roll. So chapter two will be focused on. Sorry, my bad. So chapter two, we're going to focus on first chapter, which is the limits and derivatives. So chapter 2.1, limits and derivatives. So we're going to focus on this chapter. We're going to, like I said, we're going to do one master question that involves everything that uh, you know involved in this chapter. So let's begin. We're going to do two master questions for specifically for this question. The first one would be so master question one. Where we're going to have s of t is equal to 2t square plus, not plus, minus 4t. So 2t square minus 4t plus 1. Now we need to find the instantaneous velocity at t is equal to 2. So our what are we told exactly? Sorry that I coughed. So what exactly are we told? Like what are we exactly told here? So step 1, observe the given criteria. So what exactly are we trying to find? So we see that the equation is given 2t square minus 4t plus 1, and then we see the instantaneous velocity at t equals 2. So we need to find the instantaneous velocity at t equals 2. Now because this is limits and derivatives, we want to find the instantaneous velocity, meaning we want to find the velocity at one point. Instantaneous velocity means what? Instantaneous velocity simply means at one point, right? Instantaneous velocity means the velocity at exactly one point, meaning our v will be that limit as h approaches 0, s of plus h minus s of divided by h. This will be the change in time, and this will be the change in position, right? This will be the change in position. This will be the change in time. And we did those in chapter 1. We need to first find the S of 2. So step 2, get the S of 2 equation. So S of 2 is so 2 square minus 4 2 plus 1. So 2 square minus 4 2 plus 1. You can calculate if you want. So 2, I'm just going to charge my Apple Pencil. So 2 square, so 2 4 8. 8 minus 8 0 plus 1, so s of 2 will be 1, and then s of 2, let's discharge. So we have s of 2 being 2 multiplied by 4 minus 4 times 2, which is 8 minus 8. 8 minus 8 is 0. 0 plus 1 is 1. And then s of 2 plus h would be 2. 2 plus h whole square minus 2. 2 plus h plus 1. So 2 4 plus 4h plus h square minus 8 plus 4h plus 1. So 8 plus 8h plus 2h square minus 8 minus 4h plus 1. And so 819 plus 4h. Oh, sorry, not 9. We have 8, 0, 1. So 2h square minus 4h plus 1. So this is your S of plus h. Cool. So for S of 2 is 1 and S of 2 plus h is 2h square. 2h square minus, okay, wait, there's the, there. There will be 2h square minus 8h, 4h plus 1. Right, so 2h square minus 4h plus 1. Then what we're going to do is step 3, build the fraction. The fraction that we have, this S of 2 minus h divided by S of 2 minus h minus S of 2 divided by h. So S of 2 minus h, going to have 2h square minus 4h plus 1 minus 1 divided by h. So 1 minus 1, 0. So 2h square minus 4h divided by h. So 2h minus 4. Am I right? 2h square minus 4h plus 1 minus 1. Or did I make a mistake? 8 is 0, 0 and 1, 1. 8h, 4h minus 4h, 2h square minus 4h. We good. So it'll be 2h square minus 4h divided by h, which is 2h minus 4. Now, your limit as h approaches 0, 2h minus 4. What you're going to do is, as h, this equation approaches 0, so 2h minus 4 will be 0, then your overall equation, so h approaching 0, your maximum value will be minus 4, which means not minus, is it minus 4? Okay, wait, why is it subtraction? I need to check one thing. Did I make a mistake? So 4 plus 4h plus h square minus 8 minus 4h. So minus 8. So this will be 8 plus 4h. So minus 8 minus 4h. Yeah, that's correct. Because this is 8 plus 4h. And then if I have a subtraction, minus 8 minus 4h plus 1. And then 8, so 8 plus 8h plus 2h square minus 8h minus 4h plus 1. So 8 minus 8 is 0. 0 plus 1 is 1. 8h minus 4h plus 4h. This will be plus 4h. So now this will end up as 4 minus 2h. 4 minus 2h. So now you have 4 minus 2h as h approaches 0. Then your v of 2 will approach 4. Right? So as h approaches 0, your 2h minus 4, sorry, as h approaches 0, v of 2 will be 4 as h approaches 0. So v of 2 approaches 4 as h approaches 0. Pretty much the same thing like you do with the substitution and stuff like that. It's pretty simple. Hope you understood. We will do another question. We will do another question. That's completely fine. This time just focus what's going on. So S, we're going to do another question. Master question 2. So S of t is equal to 3t square plus 2t. And we need to find the instantaneous velocity at t is equal to 1. So which means we need to do v of 1. Watch carefully. V of 1 is equal to s of 1 plus h minus s of 1 divided by h. What was your equation? 3t square. So 3t square plus 2t. So if I have s of 1, so s of, oh shoot, s of h is equal to, I'm not writing step 1, step 2, step 3 because I did that. You have to watch carefully. So s of h would be 3t square minus 2t. S of 1 will be 3 minus 2, which is equal to 1. S of 1 plus h will be 3, 1 plus h whole square minus 2, 1 plus h. So 3, 1 plus 2h plus h square minus 2 minus 2h. I'm going to have 3 plus 6h plus 3h square minus 2 minus 2h. And I'm going to have 3, 2, 1, 6h, 2h, 4h plus 3h square. Or I can write 3h square plus 4h plus 1. And then I'm going to bring that fraction, which is limit as h approaches 0, s of 1 plus h minus s of 1 divided by h, which is 3h square plus 4h plus 1 minus 1. I'm going to have 3h square, decrease that. I'm going to have 3h square minus 4h divided by h, right? So 3h square minus 4h divided by h, which will then turn out 3h minus 4. Now limit as h approaches 0, and if you turn this to 0, your v of 1 will approach minus 1. Your v of h will approach, is it minus 1? Okay, now I need to, why would it be minus? Let me check. Wait, 3h square plus 4h plus 1 minus 1. So that's correct. I'm going to have 3h minus 4. All right. 1 square, which is 1 plus 2h. So 1 plus 2h plus h square minus 2 minus, or if I write 2 plus 2h, and if I have a subtraction, then I'm going to have minus 2 minus 2h. So I'm going to end up as 3 plus 6h minus 3h square minus 3h plus 3h square minus 2 minus 2h. So 3 is there. So 3 minus 2 is 1. 6h minus 2h is 4h. And 3h square. So technically it is 3h square plus 4h. Wait, I'm confused. Am I making a mistake here? So I have, well, let's see, minus of 2, 1 plus h. Is it 1? It's 1 plus h, right? Because if I have, oh, now I get it. Now I get it. I wrote uh 1 here because it should be 3t, but you get the idea, right? Let's keep it, let's say there is 1. Let's say that if limit as h approaches 0, then v of 1 would be 3, 0 minus 4, which is minus 1 meter per second. For now, we're going to say 1 meter per second, but you get the idea, right? You get the idea. The mistake I made was that I wrote 3t square minus 2t instead of 3t square plus 2t. So I was using 1 the entire time instead of using 5. So it's my fault. But you get the idea. Like the step by step doesn't change. Whatever the case, the step by step does not change, right? So this marks the end of section 2.1. Like I said, it's not meant to be that hard. If you did not understand, just feel free to email, feel free to message, feel free to comment, feel free to say anything. I'm going to explain again. One way again, right? So we're gonna see you on section 2.2.